Oh, Ralph, how I envy your optimism. There is no Springfield 50 years in the future. With global warming trapping the CO2 inside our poisonous atmosphere, our superheated oceans will rise, drowning our lowlands, leaving what's left of humanity baking in deserts that once fed the world. And in the new Nineveh, darkness falls.
I'm going to talk about existential threats and climate policy. I'm going to talk about a couple of things. I'm going to actually spend a lot of time on the notion that climate change is an existential threat. This is mostly in response to the lecture I gave in the same place last year, where your predecessors challenged me on this particular point. And we'll also talk about estimates of the impacts of climate change. And I'm going to talk a lot about the sort of the political economy around portraying the impacts of climate change. I'm going to talk a little bit about the design of climate policy. And I'm going to talk about the state of the climate debate. And I'm going to take this existential threat literally. I know that in modern English, literally also is a sign of emphasis, but we're at a university, right? So we should take words seriously. And that's what I'm going to do. The girl that you see looks very good for a zombie. There's a lot of people who think that climate change is really an existential threat.
Shitting themselves about what's happening for the future. They've got another 50, 60, 70 years to live on this planet. By that time, there could be only 1 billion people left. That's 6 billion people that have died from starvation or been slaughtered in war.
That was Roger Hallam, the foundation of Extinction Rebellion. You may have seen signs like this. Extinction Rebellion is, of course, one of the major NGOs, activist groups in climate change at the moment, climate policy at the moment. You may have seen signs like this. You may have heard of Leonardo DiCaprio, right? If we do not act together, we will surely perish. It suggests that, yes, we will literally die of climate change. David Attenborough is a bit more optimistic, only talks about the collapse of civilization. Christine Lagarde, the current head of the European Central Bank, thinks that because of climate change, future generations will be roasted, toasted, fried, and grilled. Ban Ki-moon, the previous Secretary General of the United Nations, is very worried about climate change. Emmanuel Macron, the current president of France, talks about destroying the planet. Angela Merkel, dramatic damages. Desmond Tutu equates climate policy to fighting apartheid. Barack Obama, the previous president of the United States, talks about saving the planet. So there's a lot of people who really think that climate change is, including people in positions of influence, who really think that climate change is a very big threat. And this is Bill Nye, the science guy. If you have ever visited America, you would know who he is. Talks about climate change with a globe on fire, literal fire. Greta Thunberg, probably closer to your home. I don't want your hope. I don't want you to be hopeful. I want you to panic and act as if the house was on fire. And here we have another favorite.
And people, and Gen Z and all these folks that come after us are looking up, and we're like, the world is going to end in 12 years if we don't address climate change. And your biggest issue is your biggest issue is how are we going to pay for it?
That's Alexandria Ocasio-Cortez, of course. This happened only on Monday.
How we deal with climate change, which, as you indicated, is an existential threat to the planet.
And here is Alexandria Ocasio-Cortez again.
So much long because of the climate crisis. We only have a few months left. I love that you support the Green Deal, but it's not getting rid of fossil fuel. It's not going to solve the problem fast enough. A Swedish professor saying that we can eat dead people, but that's not fast enough. So I think your next campaign slogan has to be this: we got to start eating babies. We don't have enough time. There's too much CO2. All of you, you're pollutant. Too much CO2. We have to start now, please. You are so great. I'm so happy that you're really supporting the Green Deal, but it's not enough. Even if we would bomb Russia, we still have too many people, too much pollution. So we have to get rid of the babies. That's a big problem. Just stopping having babies is not enough. We need to eat the babies. This is very serious. Please give a response.
Thank you. One of the things that's very important to us is that we need to treat the climate crisis with the urgency that it does present. Luckily, we have more than a few months. We do need to hit net zero in several years. But I think we all need to understand that there are a lot of solutions that we have and that we can pursue, and that if we act in a positive way, there's space for hope. We are never beyond hope.
Okay, AOC got swifted there, but there's a lot of people who think that climate change is a really, really urgent problem. And we've seen things like this in the media for a long time now. 100 Days to Save the World. Note the date on this particular piece in CNN. This was from 5 years ago. And of course, this goes back further in time as well.
You should just come over. We had 5 years at the science. Blue sky wept when he told us Earth was really dying. 5 years, that's all we got. We got 5 years.
For those of you who didn't recognize him, that was David Bowie. For those of you who have no sense of fashion history, this was the early 70s. So this notion of an imminent environmental threat is actually very old. And there is a widespread belief that climate change is literally an existential threat. What you're looking at is the results of a survey that was done last year. And at the very bottom, so what we're looking at is what people think about the implications of climate change, serious economic damage to the global economy. The vast majority of people seem to believe that. My mouse actually works. But at the very bottom, you're looking at the extinction of the human race, where in Asia and the Pacific countries, actually in most of these countries, a majority of people seem to think that this is on the cards. But also in European countries, in the sort of bluish green, you see that in some countries, there's actually a majority of people who think this. And in all countries, there is a significant minority who think that climate change literally will cause the extinction of the human race. I won't go through everything that is there, but I will look at 3 particular assertions. We're all going to drown because of sea level rise. We're all going to starve because of shortages of food, and we're all going to fry. I could make the list much longer, but we don't have all day. So let's start with sea level rise. So this is the current North Sea. You see England, you see the Netherlands. This is the same map after 1 meter sea level rise, after 5 meters sea level rise, after 50 meters sea level rise, and you see, yeah, this is really, really a big thing. Similar information here, but now for the world as a whole. If you look at the world maps, this is what the world will look like in 80 years, in 800 years, in 8,000 years, and you see that, yeah, the world map is starting to change because of sea level rise. If you look at which cities are where, Venice is, of course, pretty low. Amsterdam is pretty low. Los Angeles is not that high either. And if sea level rise goes up and up and up, it starts affecting Hamburg and San Francisco and London and Shanghai and so on and so forth. And this seems to be a really, really serious problem. The same picture here. This is done by geologists who have a very weird perception of time. So 20,000 years is 20,000 years in the past, and then the minus 10,000 is into the future. And you see the past evolution of sea level rise. This is where we are today. And this is where we may end up in the future if Greenland melts, if West Antarctica slides into sea, and if East Antarctica starts melting. And then you're talking easily about 50 meters of sea level rise, which sounds pretty extreme. You can't see me, you can only see me sitting down. I'm almost 2 meters tall. 50 meters is 25 me's stacked on top of each other. That's quite a bit of water, right? And then if you start looking at the time scale, this is a model simulation, and the end of the millennium, sea level rise may be 7 meters, but at the end of the century, it's only 60 centimeters or so. The water is coming up to slightly above my knees, which all of a sudden starts sounding a lot less dramatic. By the end of your lifetime, sea level may have risen by 60, perhaps 80 centimeters relative to what it is today. So these very dramatic pictures of all major cities in the world disappearing under the surface of the ocean, that is all something that will happen perhaps towards the end of the millennium, perhaps in the next millennium. So this is something for your great grandchildren to worry about. Long-term projections are, of course, that by then the human population will be much smaller than it is now because of natural movements in fertility in particular. Could a little bit of sea level rise, 50 centimeters, do much? And that is what is projected over my lifetime, my remaining lifetime. What you're looking at here are two pictures of Hulu-Male, 20 years apart. And we've seen sea level rise in the past, right? I mean, climate change started, or human-induced climate change started about 200 years ago, and the oceans have been expanding in the past and also in the recent past. What you're looking at here is what that did to Hulu-Male, right? Which is just next to the main island of the Maldives. And the top picture, you see the situation completely deserted, almost completely destroyed, you would think. And in the bottom picture, you're looking at a vibrant airport and a large business district and a large living quarters. Now that is the interpretation that you may intuitively give to the satellite pictures taken 20 years apart. But the bottom picture is actually the recent one. And the top picture is what Hulu-Male looked at 20 years ago. So the Maldives is a poster child for the impacts of climate change. And they get away with this because very few people visit the Maldives. But if you were to go, you would notice that they're actually rapidly building up the country, as you can see, and all these new developments are protected against sea level rise because of dikes, because of raised structures, and so on and so forth. And we should, of course, not forget that every time you read in the newspaper that this particular city will be very hard hit by sea level rise, and basically every city has been projected to be hit hard by sea level rise by now. You should not forget that the ancient Sumerians and the ancient Chinese around 5,000 years ago, independently of another, invented the dike, right? And coastal or flood protection, coastal zone protection, river flood protection goes back thousands of years. And the people on the Maldives are actually well aware of this and perfectly capable of protecting themselves against sea level rise. So that was the first assertion. We're all going to drown. Well, no, we're not. The second assertion that I was going to talk about is we're all going to starve. Will it be the case that because of climate change, we will run out of food? What you're looking at here are 6 graphs from the previous report of the Intergovernmental Panel on Climate Change. The next one will come out in a year or so from now. So this is the current best overview of the science. You're looking at, in the columns, temperate regions versus the tropical regions. And you're looking at the 3 major crops: maize at the top, wheat in the middle, and rice at the bottom. And this is essentially where we get most of our calories from. This is what feeds humans. So this is important to us. Then on the horizontal axis, you're looking at scenarios of climate change, the increase in local mean temperature. This is, of course, not just temperature that is changing. Radiation is changing, rainfall is changing, wind is changing, everything is changing with the change in the mean temperature. Of course, temperature extremes are also changing. So that is on the horizontal axis, and on the vertical axis, you're looking at the projected yield change because of climate change. And the yield is essentially how many tons of grain do you get from a hectare of cropland. You focus on the red results for the beginning. The dots are original primary estimates, and then the sort of the curve, that is the line that is fitted through it, is an indication of where the average of the literature is going. And you see negative impacts across the board, right? Maize is going down by perhaps 10% in the temperate regions on average, but there's much more dramatic projections as well. It's going down maybe 50%. Wheat in the tropics. This differential pattern is immediately clear to anybody who understands crops. Maize is a heat-loving crop. Wheat is a cold-loving crop, so that gets hit much harder. At the very bottom, you see rice, which is another heat-loving crop, and the negative effects are much more limited here, although in some places they're actually quite large. Then in blue, you're looking at, so in red, the assumptions here is that climate is changing, but farmers do not change their behavior, which is a slightly peculiar assumption. So these farmers sit on their farms, they see their crops fail year after year after year, and they continue to plant the same variety at the same time, give the same amount of irrigation, the same amount of pesticides, and harvest at the same time, even though it sort of fails year after year after year. In blue, you're looking at the same crops, the same studies roughly, but now with on-farm adaptation, that farmers actually recognize, circumstances have changed, perhaps I should change my planting dates or the cultivar, something like that. And then immediately you see that the impacts become far less dramatic, and you see positive impacts for rice in the tropics and essentially zero impacts for maize in the temperate zone, rather than these negative impacts. So a lot of these stories about starvation because of climate change are really focusing on these very few, very negative studies that don't regard, that assume that farmers are sort of stupid and don't change their behavior. There's another thing that is important here. What you're looking at, the 2 top graphs, is how did yields change over time, going back to the 1940s or even the 1900s. And what you see is a fairly steady growth in the yield, the amount of grain that you can get from a hectare of cropland. And the reason is technological progress. better machinery, better cultivars, better fertilizers. We go back to the 1900s, really much better fertilizers, and so on and so forth. And these trends that you're looking at, the bottom two graphs have the growth rates. You may be talking about a 2% growth rate over time, maybe a 1% growth rate over time. And of course, if that accumulates over a century or so, you're talking about quite a substantial increase in yields, a factor 9 in the case of maize over the last 120 years. Which of course is much, much larger than the halving of crops, crop yields that you see in this particular picture. So technological change in agriculture actually is already strong enough to overcome the negative impacts of climate change. And that becomes even more pronounced if you look at this particular map. What you're looking at here is the so-called yield gap, which measures how much the average commercial or subsistence farmer gets of their land compared to a model farm that operates on the same soils with the same climate, but of course the latest technologies and the latest farming techniques. So essentially every country in the world has an agricultural extension service. And one of the things that these agricultural extension services do is they have sort of these model farms in which they plant things and they optimize for the local circumstances, and then they invite farmers to come and learn from this. That's essentially what they do. And in the Netherlands, that would be Wageningen University, who fulfills that role. Now, if you look at Europe or you look at North America, then what actual farmers do is very close to, or what actual farmers get of their land is very close to what the sort of scientifically trained university farmers do get of their land. And the yield gap is 10, perhaps 20%. If you go to Africa, then the yield gap is 50% in the yellows, 70% in the oranges, up to 90% in the reds. And that means that the model farm working on the same soil in the same climate gets 10 times as much from their land as the average subsistence farmer that you see here. Again, we're talking about a factor 10 difference, which puts these numbers into quite some perspective. So if after a century, because of climate change, your crop yields have halved, but you move farmers to the current state of the art, then their yields would increase by a factor 10. And if you then put technological change on top, then their crop yields will go up by a factor 10 again, so that makes 100. And then if you halve them, you have 50 times as much food coming off your land. So again, climate change has negative impacts for crop production, for food production, but it does not mean that we will run out of food, because climate change is much, much weaker than technological change or the diffusion of technology. The third claim that I want to talk about is we're all going to fry. This is from a study that appeared, I believe, 2 years ago now, and it projects the number of days of deadly heat by the year 2100. And in the very dark, essentially all year round, heat is deadly. But in the yellows, you would see that, every third day or so, and of course concentrated in summer, will be deadly. And of course, you only need to die one time, right? So you need to have only 1 day of deadly heat to die. So this looks particularly seriously until you read the fine print of the paper, because according to this particular model, at this moment in the year 2020, or rather in the year 2018 when this came out, 30% of the world's human population is exposed to such deadly conditions each year. So the word deadly does not mean what you think it means, because the mortality rate is not 30%, right? So it's a bit unclear why they picked the word deadly here, because it's clear that people are not dying. There is another thing going on here. What you're looking at here is the sales of air conditioning in the year 2016, the last year for which we have data. And what you see is that these things, yes, are selling quite well at the moment, particularly in China, which is rapidly getting richer, but also in India. You see quite substantial sales of residential air conditioning. This interprets these particular studies. The sort of the reddish colors, these are cooling degree days. So this is the days that you need to switch on your air conditioner times the intensity of that air conditioning. And the redder colors are hot and the bluer colors are cold. So that is one thing you see on this graph. And the second thing that you see on this graph is as people grow richer, they start buying more air conditioners. And then on the vertical axis, you're looking at the penetration rate of residential air conditioning, people having air conditioners in their homes. This is obviously a simulation study fed by data like this that I just showed you. And if we put these two relationships together and project them into the future, then by the year 2015, you would actually expect to see many, many people, including people in the hottest countries, to have air conditioning. And this is the projection over time. And you see that most of the expansion is in places like China and India, rest of the world, of course, as well. Even in Indonesia, which is fairly poor still, you see a substantial penetration of air conditioners in homes. And the same is true if you do this for commercial air conditioning. The black line there, so the regions of the world again, and in black you're looking at the penetration rate. And what you see is that the expectation, if current income growth continues, then by the middle of the century, a lot of places will simply be air conditioned. And that immediately implies that you will not fry because of climate change. So is climate change an existential threat? No. There's absolutely nothing in the literature that suggests human extinction or even large-scale mortality. That is simply not on the cards. To my mind, it is very peculiar that people even think about this, because if you look at where humans live at the moment, some people live on the North Pole or very close to the North Pole. People survive on the South Pole. Some people live in the rainforest. Some people live in the desert. It is clear that human life is compatible with a large range of temperatures and rainfalls. If you look at it historically, we as a species made it through 4 ice ages, including the warming in between. And of course, at those times, our technologies were definitely a lot more primitive than they are now. And from those two considerations, you can conclude that we're the ultimate generalist. We're much better able than any other species to adapt to our natural environments. And of course, we've also become pretty good at adapting our natural environment to our needs. So no, climate change will not cause a lot of death, and it will definitely not lead to human extinction. That is not to say that climate change is not a problem. It is, and it's particularly in poorer countries. So this morning you talked about the DICE model. And one of the aspects of the DICE model is that it has an impact function that will tell you how much damage will be done because of climate change. Now, Nordhaus assumes a quadratic function that is always negative. This is a meta-analysis of the literature. The blue dots that you're looking at are the original studies of what will climate change do to human welfare. And then the red curve is sort of fitted through. This is a meta curve fitted through the primary estimates. And Nordhaus is somewhere in here. Now, what does this graph mean? On the horizontal axis, you're looking at scenarios of climate change, and the severity of climate change is here indexed by the change in the global mean surface air temperature. Of course, it does not mean that warming or global average warming is the only thing that matters, right? That's actually one of the least important things. And then on the vertical axis, you're looking at the welfare equivalent income change, or the Hicksian equivalent variation, which essentially tells you that if the world were to warm by 2.5 degrees, then the average person on the planet would feel as if she had lost 1.3% of her income. That is how you should read this. It's not to say that the average person has lost 1.3% of her income, but rather that she feels as if she had lost 1.3% of her income. Now, what do these stories, this graph tell us? First, we see positive effects of initial climate change. The reason for this is that if winters are warmer, you need to heat your home less and you save money. If winters are warmer, few people succumb to cold-related deaths, which actually outweigh heat-related deaths. Of course, climate change is driven by an accumulation of CO2 in the atmosphere, and CO2 is plant food, so crops grow faster, and more CO2 in the atmosphere also means that plants become more water efficient. So these are all positive effects, and for the initial warming, they actually dominate the negative effects. Now, it's important to note that this graph here, the 0 here, is the year 1750, and we're already at 1 degree of warming or so. And that means that the initial effects of climate change, the positive effects, are actually in the past, because of the long delays in the ocean and in the energy system and so on and so forth. We're going to warm another 1, perhaps 2 degrees, regardless of what we do. So these initial positive effects are sunk, right? It's not, they do not affect, should not affect our decisions. So that is one thing that you see. Another thing that you see is that as climate change gets worse, the negative effects get larger, and no surprise there. Actually, at greater degrees of warming, the negative effects, sea level rise and spread of tropical diseases, the additional cost of air conditioning, the additional cost of coastal protection, and so on and so forth, start to dominate the positive effects. And of course, that gets progressively worse as the climate warms further. Another thing that you notice is that there is actually a rough agreement between experts. All the blue dots are different studies. There's a rough agreement on the size of the effect. And this is a good thing. Because different studies have used different methods to estimate this, have made different assumptions, but have also used completely different methods. And some of these people obviously know each other, and some people here are students of other people that you see in the sample. But there's also some quite antagonistic relationships between some of the groups. And the fact that people roughly come up with the same order of magnitude, if not, of course, total agreement, right? There's a fair spread here, gives some confidence in this. And the final thing, the effect size, and that is important to emphasize in this particular context, is that 2.5 degrees of warming would lead to an equivalent 1.3% income loss. 2.5 degrees of warming is something we can expect in 50, perhaps 80 years. So really the effect size here is that 100 years of climate change is about as bad as losing a year of economic growth. That is the order of magnitude that we're talking about. But you should not take that too literal, because if we focus on the uncertainty, then we see that the uncertainty is large, and the dotted lines are only the 70% confidence interval. Are large, the uncertainties, but they're also asymmetric. That is, positive surprises of positive surprises of equal but opposite magnitude are much less likely than negative surprises. I've given you a couple of the horror stories of climate change already. They are easy to find. You just open The Guardian any day of the week and you find a horror story about climate change. But stories that we all be blissfully happy because of climate change, they are simply not there. And that is not just a matter of which newspapers you read or which websites you frequent. These stories are simply not there. These sort of the most optimistic projections of the impacts of climate change is that it doesn't matter much. So negative shocks are much, much more likely than positive shocks. And if you account for this uncertainty, then the statement that I just made, that a century of climate change is about as bad as losing a year of economic growth. If you include the uncertainty, then really a better statement would be that a century of climate change is about as bad as losing 10 years of economic growth, which is not the end of the world, right? By now, Japan has lost 20 years of economic growth already. And they're still fairly happy and fairly well-to-do. So this is what happens at the world average. This is the same data, the same meta-analysis, but now across the globe. So we're focusing on the 2.5 degrees of warming, but instead of looking at what's happening at the world average over time, we're going to focus on the 2.5 degrees, and we're going to look at over space. And this is for all the 200 or so countries in the world, and they're ordered according to their per capita income. And note, this is a log scale, right? So we go from 10, well, actually a bit higher than that, all the way up to 100,000. And what you see is a very clear pattern. Poorer countries are much more vulnerable to climate change than our richer countries. The positive impacts of climate change are concentrated in rich countries, but not in the poor. And this is a very clear pattern. There's, of course, a few exceptions here. Singapore is very rich, but also very hot, and therefore would see negative impacts. A place like Mongolia or Bhutan, you are very poor, but are also fairly cold. Bhutan because it's high up in the mountains, Mongolia because it's actually fairly far north. And they would see not nearly as negative impacts as some of the poor countries in the tropics. But this is a clear pattern that we see, that most negative impacts of climate change are concentrated in the poor countries. And that is for 3 reasons. One is exposure. Poorer countries have a much larger share of their economic activity in agriculture, are therefore directly exposed to the weather, whereas in rich countries, if you look at the Netherlands, what does the Netherlands do? It does finance, it does publishing, and those sort of things where the link to weather and climate is very, very weak and distant. So that is the first reason why poorer countries are much more vulnerable to climate change than our rich countries. The second reason is that poorer countries tend to be in hotter places. So this is the same data, but now the horizontal axis has changed to the current temperature. What you see is that the large negative impacts are concentrated in the hot parts of the world, whereas the positive impacts are concentrated in the cold parts of the world. No surprise there. has to do with available technologies and how plants and animals can cope. The plants and animals that we rely on can cope with the weather. It also has to do with the ability to adapt. If you wonder what will Amsterdam be like if it's 2 or 3 degrees warmer, then you should look at Paris, you should look at Madrid, you should look at Barcelona. How do people cope there? And you see later dinners, and you see buildings that are designed to keep their heat out rather than the heat in, as we do in Northern Europe. And you see a whole range of different technologies and different behaviors that people have used to cope with the warmer weather. So for a city like Amsterdam, it is the question, what should we do if it gets warmer, is relatively simple. We copy what people in Madrid have been doing. And therefore, we know what to do. If you live in the hottest place on the planet, you live in Singapore, and you live in Dar es Salaam, then you cannot copy somebody else's behavior. You cannot adapt somebody else's technology, because that doesn't exist. You have to invent it from scratch, which is simply much, much more difficult than copying what the Spaniards are doing. And that explains why hotter countries are more vulnerable to climate change than our richer, poorer countries, colder countries, sorry. And the third reason is adaptive capacity. I talked about sea level rise already. If you want to cope with sea level rise, what you need to do is you need to build seawalls and dikes and those sort of things. So the first thing you need is to know how to do that. So you need to have access, you need to have awareness of the technology, and poorer countries have less technological know-how than have richer countries. The second thing is that you need to be able to pay for these things. You may know how to build a dike, but if you can't afford to build a dike, it's no good. And the third thing that you need is that you need to be able to mobilize the resources to build those dikes. So coastal protection is a classic public good. It's best built by the government. But if you have a government that cannot raise taxes, for instance, which you see in the very poorest countries, or a government that is very corrupt, that if it raises taxes, they somehow disappear into Swiss bank accounts. Or if you have a government that doesn't care about the poor, as we see in places like Bangladesh, then it is no good that you know how to build a dike, and on average you would have the money to build for the dike, but if you don't mobilize society to do this, it doesn't help. And all three things are lacking in poorer countries. It's actually a symptom of as well as a cause of underdevelopment, that poorer countries have worse governments, and that makes the public policy part of adaptation much, much more difficult, and that immediately implies that poorer countries are much more vulnerable to climate change than our richer countries. So, where are we? The impact of climate change on human welfare appears to be modest, and we've known this since Nordhaus's paper in the Economic Journal of 1991. And the larger impacts of climate change, the more negative ones, the more worrisome ones, appear to be symptoms of underdevelopment and mismanagement rather than impacts of climate change. And we've known this since Schelling's paper in the American Economic Review of 1992. Which is, and both these guys have won the Nobel Prize. And these are old papers, so how come people believe that climate change is an existential threat? Where does this come from? I ended with the question, why do people believe that climate change is an existential threat? There's actually a very long history of millenarianism. What you see is the four horsemen of the apocalypse, that's pestilence, war, famine, and death, and all these themes return in the press, media, talking about climate change, as you see here. There's pestilence, there's war, there's famine, and there's death, all associated to climate change. And that is no surprise at all. The old stories are the best, or rather, the good stories get old. And if you want to tell a narrative, if you want to be a successful journalist and sell newspapers, or if you want to be a successful environmentalist and get lots of donations, then it's best to cast your story in a story that people already know. And here you see the Four Horsemen again, but now in the BBC series of The Good Omen. Politicians also like to cast their story in these sort of known themes, and of course they all like to be Bruce Willis. They like to save the planet. What better legacy than to tell your grandchildren that when you were prime minister, you saved the planet, right? So this is very natural for actors in climate policy to behave this particular way. How would you actually want to design climate policy? If you were not encumbered by the need to get elected, or to collect donations, or to sell newspapers, what would you actually do? Well, the cheapest way to meet any targets, including targets for greenhouse gas emission reductions, is to equate the cost of emission reduction at the margin. This is a very simple, actually marginal principle. If it's cheaper to reduce emissions from company A than from company B, then company A should work harder. And by just rearranging who does what, if you can save money and reduce the same amount of emissions, this is simply a smart thing to do. And the way to guarantee that you have equal emission reduction costs at the margin is either by imposing a uniform carbon tax, everybody pays the same for their emissions, or through a system of cap and trade with tradable emission permits. A carbon tax, the good thing about carbon taxes is that they bring price certainty. Good thing about tradable permits is that they bring certainty about the amount of emissions that you put in the atmosphere. But because climate change depends on the accumulation of CO2 across all sectors, across all countries, and over time, it's a stock problem, that emission certainty doesn't matter much, because if you make a mistake in the Netherlands with your emissions for the year 2020, that doesn't really affect the climate. If you reduce your emissions by a little bit too less or a little bit too much, that does not really affect the climate, because climate depends on global emissions accumulated over decades. So knowing exactly how much emissions, how high your emissions will be next year is actually not worth a lot. Whereas if you get your policy too stringent by accident, then of course you do impose a substantial cost on your economy. So the price certainty that carbon taxes bring are actually much more important than the emission certainty that tradable permits bring. And that has led the economists for a long time now have a consensus that what you really need for climate policy is a carbon tax, a uniform carbon tax, and nothing but a carbon tax. So it's a fairly simple climate policy design. And then over time, again, for reasons of arbitrage, you essentially want this carbon tax to increase with something like the rate of interest over time. Otherwise, again, if you rearrange your emission reduction over time, you could simply save money while cutting emissions by the same amount. So climate policy design, according to textbooks on economics, on environmental policy, fit on one sheet, right? They fit on one slide. This is what you want to do. This is, of course, not what has happened, right? If you go back to this particular picture of total economic impact of climate change, this, of course, also implies a marginal impact of climate change. And here you're looking at another meta-analysis of the so-called social cost of carbon. This is the PIGU tax. This is how much, what sort of a tax we would want to put on greenhouse gas emissions. There's been over 1,700 estimates of this published now, and that means that you can fit a nice kernel function through it, and that's what you're looking at. And there's a couple of things that you see. So this is a probability density function. That's the probability mass, probability density, I should say, is on the vertical axis. On the horizontal axis, you're looking at the carbon tax that you want to impose, and then in different colors, you're looking at different utility discount rates that people have assumed. Not sure that Onno has explained it yet, but the discount rate is essentially 2 plus the number that you see here. So if you use a 5% discount rate, then you find a brown curve, and your expected PIGU tax, your expected social cost of carbon, the mean of the curve that you see here is around 63. And then if you use a lower discount rate, it goes up to 390. And if you use a very low discount rate, it goes up to $630 per ton of carbon. Now, to put things into perspective, because you guys don't think in terms of dollars per ton of carbon, there's only a few people on the planet who do that. The current price of emission permits is around $100 per ton of carbon. This is actually before the pandemic. It's a bit lower now. So I suggest that the EU policy actually roughly equals the PIGU tax. It actually passes a cost-benefit test according to the standards as laid out in the DICE model that you discussed earlier today. Of course, if you use a lower discount rate, then your carbon tax, your desired, your preferred carbon tax goes up. And the reason for that is very simple. The lower the discount rate, the more you care about the future. The more you care about the future, the more you care about climate change, because it's largely a future problem. And the more you care about climate change, the harder you would want to work on reducing it. That is, the higher the carbon tax you would want to impose, right? So this is roughly what you would want to do in a cost-benefit analysis. What can you buy for this? Let's look at these particular pictures again. This is from the previous IPCC report in the Governmental Panel on Climate Change, where they look at a whole bunch of targets in the long run, and then they use a whole bunch of models to see what are the implications for different policy choices that you see depicted here. For the carbon taxes over time, 2020 to the year 2100, what does that imply for this graph is not relevant. What that is implied for consumption losses, for GDP, and so on and so forth. It's important to know that if you want to go to really steep or really low temperatures, and these dark blue and the light blue is roughly in line with the Paris Agreement, then it is not enough to cut emissions to zero. Really, in the long run, and that is what is shown here. At the top, we're looking at methane. At the bottom, we're looking at CO2, and the bars that you see denote how high emissions would be in the year 2020. This must be 2020. This was done a while ago. 2050 and 2100. This is dropped off the graph, right? Yeah, 2030, 2050, and 2100 is what we're looking at. 2030, 2050, 2100. What emissions would be relative to the year 2010. And what you see here is that emissions go negative. That is, that emission reduction needs to be more than 100%, which means that we are sucking CO2 out of the atmosphere rather than adding to it. So what are the prices that you would need to pay? Well, in the near term, and this report came out 6 years ago, so 2020 was the near term rather than the present. You would want to impose global carbon taxes somewhere between $10 and $100 per ton of CO2, which is somewhere between 2.5 and 25. No, it's somewhere between $25 and $250 per ton of C. And that is well within the range of current climate policy in the EU. So in order to get to the Paris Agreement, what we should have done by this year is convince the entire world to adopt a climate policy that is equally stringent as the EU did, which is, of course, not what happened. And then over time, you need to accelerate this price. And by the end of the century, by the end of your lifetime, and this is again a logarithmic scale, that goes from, say, 100 to up to 10,000, right? So that's a price increase of a factor 100 over an 80-year period. So that's a fairly steep increase in carbon prices. So this is what we would need to do in order to get to the Paris Agreement. Of course, you can also adapt less stringent targets, and then the prices are an order of magnitude. The carbon prices are an order of magnitude less. This is not going to cost the world. What you're looking at here is perhaps the best welfare indicator, the consumption losses over this period. And what you see is great uncertainty in the short run and greater uncertainty in the long run. No surprises there. The future is always uncertain. But the important thing here is the vertical scale. So how much of consumption would be lost on average? Well, the most pessimistic models in the most stringent scenarios say 10%. A 10% consumption loss over an 80-year period is again very small compared to economic growth. 10%, losing 10% of your consumption is big if you get that hit, as a number of people or many people are doing at the moment. If you get that hit in a week or so, but if you smear it out over 80 years, it's actually very small. So by now you may be even more confused about what I'm saying, right? I started by saying, well, climate change is actually not that big of a problem. And now I've argued that climate change also has a fairly simple solution. What we want is a carbon tax, a uniform carbon tax, and nothing but a carbon tax, and that's going to cost us a small fraction of our consumption. So how did we get to these very complicated international climate negotiations? How did we get to this very polarized debate in the media? It is a simple problem with a simple solution. And there's 3 reasons for this, or I'm going to talk about 3 reasons. One, the first is that greenhouse gas emission reduction is a global public good. And international climate policy actually goes back 35 years now. For most of that period, and definitely between the first conference of the parties in 1995 in Berlin, and then the conference of the parties to the United Nations Framework Convention on Climate Change, the international climate negotiations now 11 years ago in Copenhagen, the aim was always to agree on legally binding emission targets. That is what the international negotiations were about. There would be an international treaty that would say, you, America, cut your emissions by 6%, and you, EU, cut your emissions by 8%, and that would be international law. That was the aim of the international climate negotiations, and it failed. It completely and utterly failed. Strangely enough, this was actually predicted. This was predicted before the negotiations even started by the two gentlemen you see here, Carlo Carraro in 1992 and Scott Barrett in 1994, published papers that said this is not going to work. And the reason is very simple. Greenhouse gas emission reduction is a public good. You bear the cost of emission reduction, but the benefits of emission reduction are shared across the world, and that is because the CO2 that you emit sort of spreads through the atmosphere and affects everybody's climate. So you will only get a small share of the benefit of reducing emissions falls on yourself. The vast majority of those benefits falls on other people. Public goods, if there's no central authority, which there is not in the world, are underprovided. It's as simple as that. So it took international negotiators, 15 years to rediscover this basic tenet of game theory. This simply won't work. What the international negotiations after Copenhagen have been about are the so-called intended nationally determined contributions. And there's two important things here in those four words. The contribution is a contribution to climate policy. Nationally determined means that it's no longer laid down in international law what emission reduction obligations are, but it's laid down in whatever the national policy process is. So in democratic countries, it would be a vote of parliament. In autocratic countries, it would be a decision by the president or whoever makes those decisions. So no longer an international treaty on how much each country should do, but it's become a national process. And the other thing is that these targets, these contributions are not legally binding in any sense. Or any international sense, but they are intended, they are aspirations. They're not promises, they are aspirations. And this is what is in the Paris Agreement. Essentially, the Paris Agreement obliges countries to have a climate policy, and I'll come back to that in a while if there's time. So that is the first problem, that yes, if we had a global dictator, a benevolent social planner, a philosopher queen, as Nordhaus assumes in his DICE model, then we have a simple problem with a simple solution. But because we do not have a philosopher queen, that is not the case. The second reason that climate policy is such a mess is because climate policy is a wicked problem. Now, a wicked problem is a term that is used by political scientists, and they call a problem wicked if it has no stopping rule, it does not end after a while, solutions are better or worse rather than right and wrong, and actions have irreversible consequences. And climate policy easily meets all three criteria. That is, there is no perfect, it's not that the world will end unless we do something simple. No, you can work harder or less hard on climate policy. CO2 stays in the atmosphere for a very long time. The capital stock for energy for electricity generation has a very long lifetime, so actions do have irreversible consequences. And of course, it's not going to end, climate policy is not going to end anytime soon. And that makes climate, a so-called climate policy, a so-called wicked problem. Now, the term wicked is absolutely terrible jargon, because illiteracy among 6-year-olds is also a wicked problem. Right? So you get a bunch of 6-year-olds into your classroom, they can't read, they can't write, you teach them for a year and they can write their name and they can read basic sentences, and you think you're done, and then the next cohort of illiterate 6-year-olds pops up, right? So teaching literacy to young kids is also a wicked problem. Most people would not see it that way. Most people think that it's actually a good thing to teach them, but strictly it is a wicked problem. Now, how do we solve the problem? How have we solved the problem of illiteracy among 6-year-olds? Well, we've built schools and we've built a broad political consensus that yes, we need to keep on funding those schools and we need to make sure that kids go to school, right? That is how we've solved this. Although we can't solve it, right? Because every kid that is born illiterate. And we have to start again and again and again to teach them how to read and write. And if you are familiar with the debate on primary education, you would realize that there's a lot of argument going on about how to exactly do it, and there's a lot of technical specialists looking at how to best do it, and different political parties with very different opinions on how to best do it and how much money to spend on it. But there is at the same time a almost universal consensus that yes, this is what we need to do, and we have institutions to do this. And that is how we solve a problem like literacy amongst infants or illiteracy amongst infants. And that is what we need for climate policy as well. And that is actually where the Paris Agreement is very good at. So what does the Paris Agreement say? It says that each party shall prepare, communicate, maintain successive nationally determined contributions that it intends to achieve. Parties shall pursue domestic mitigation measures with the aim of achieving objectives of such contributions, and so on and so forth. Each party's successive nationally determined contribution will represent a progression beyond the party's then current nationally determined contribution. You can adjust your contribution with a view of enhancing its level of ambition. So this sort of builds the momentum to do more, to keep working at it, even though we know we can't solve it, not within definitely my lifetime. You guys may see a solution by the end of your lives, but I won't. But you build the institution to keep going at it. So the Paris Agreement actually works well in that sense, and it's absolutely voluntary. So the nationally determined contributions should add up to a total global total emission reduction, and then every 5 years or so, and we haven't seen the first, so we don't know exactly what's going to happen. The global total will then be put into what is called the global stocktake, and that will inform parties whether or not they should increase their ambition or whether they're doing the right thing. But this is entirely voluntary, because compliance with what you promised, according to the Paris Agreement, will be determined by a committee in a manner that is transparent. It's always good, right? Why do we say things that we say? Why do we write things that we say? But also that committee that will judge countries' contributions to international climate policy will be non-adversarial and non-punitive. Non-punitive meaning no sanctions will be imposed if you did not do what you had promised, but the committee will also act in a non-adversarial way. That is, you can't ask pointed questions, right? So it is entirely voluntary. That makes it sort of incentive compatible, but at the same time, it makes it fairly weak. And of course, as part of the Paris Agreement, we also have Article 28.1 that specifies that somebody who has a country that has previously signed up to the agreement may withdraw, and that is of course what Mr. Trump has done, and the US will leave the Paris Agreement the day after the presidential elections. But the institution is now there, and that is actually a step forward. The Paris Agreement in Article 2 also promises to hold the increase in the global average temperature to well below 2 degrees above pre-industrial levels, and pursue, without the G, efforts to limit the temperature increase to 1.5 degrees. That target will be missed. That is simply not going to happen. And the reason for that you see in this particular picture. Perhaps you should first read the text. If you want to limit warming to 1.5 degrees, then you can work backwards from your climate model to your carbon cycle to your emissions. And that would imply, if you really want to do that, given all the uncertainties about the future, and you want to do that with a probability of more than 50%, then you can emit something like 580 tons of carbon into the atmosphere, CO2 into the atmosphere. And if you want to increase the probability from even odds to 2/3, then you can only emit 420 more billion tons of CO2. Now, that just follows from the physics and the biology and the chemistry of the problem. Now, the top graphs show, starting in the year 2018, how much CO2 we are committed to. And the reasoning here is very simple. If you focus on the purple, if you focus on power generation, the plants that make electricity, coal-fired, gas-fired, what have you, have a lifetime. For gas, it's 40 to 60 years. For coal, it can be 80 or 100 years that those plants run. So if you just take the existing stock, you look at how, when they were built, and you run them to the end of their economic lifetimes, then this is how much CO2 you would emit. And then if you add to that the existing fleet of cars, and a car has a lifetime of 10, 15 years on Dutch roads, and then you add another 10 years in roads in Turkey and Africa and those sort of places where the second-hand cars go, first to Poland, then to Turkey, then to Cameroon or someplace. You add another bit of emissions, right? So this assumes the average lifetime of a car and the average driving, the average mileage that they make, and so on and so forth. And if you start adding up all these things, then you come to a number that is the so-called committed emissions. And those committed emissions are around 850 billion tons of CO2. Whereas if we want to stay below 1.5 degrees, we can only emit 600 billion tons of CO2 extra, right? Essentially, the scenario that you're looking at here is, what if from today onwards, or rather from 2018 onwards, now 2 years ago, every new built power plant, every new built car, every new built truck, every new built house is CO2 neutral. If that is what we do, then we're gonna just blow through the 1.5 degrees, and we're actually gonna get reasonably close to the 2 degrees, right? And of course, this is not what we've done in the year 2018. China is still planning to build a whole lot of new coal-fired power plants that will sort of like start operating in the year 2025 and the year 2030. And if they're delivered in the year 2030, they need to be planned in the year 2020. And that is what they're doing at the moment. And if they're delivered in the year 2020, they will still be there in the year 2080 and probably in the year 2100 as well, right? So we're not going to meet that 2 degree target. That is simply bluster. I think it was put in the Paris Agreement to keep the environmentalists happy. I don't think that it has any realistic chance that we're going to meet that particular target. Now, back to my story. why is climate change, climate policy so particularly complicated? I talked about it being a global public good, and that makes it difficult. I talked about it being a wicked problem, and that makes it problematic. But the politics of climate is also in a bad equilibrium. And one of the things that is going on is that there's often talk about climate change is unprecedented, and therefore we should do something about it. And what you're looking at here is the so-called Vostok record. That's a place in the South Pole where they drill for ice cores. And what you look at is the CO2 concentration over the last 800,000 years, where it sort of like went between 280 and 280 or so for 800,000 years. This is roughly the period where there were anatomically modern humans. And then if you look at what happened in recent years, in 2016, we went up to 400, well outside the historical range. And of course, by now we are higher still. And some people say, well, this is a reason for concern, that this is completely unprecedented during the existence of humankind, and therefore we should do something about it. And this is your classic is-ought fallacy. And Hume wrote about that, and Moore wrote about that, called it naturalistic fallacy. And of course, Schiller is one of the main proponents of that as well. Schiller, of course, argued that the world was created by God. God is perfect, and therefore the world that God created must be perfect, right? Is Schiller's argument. But it's a complete nonsense argument when you think about it. Yes, it is true that the CO2 concentration is unprecedented over the last million years or so. If you look at schooling and how many kids go to school, that's also completely unprecedented in human history. If we look at the population living in democratic countries, that is also completely unprecedented in historical terms. And we don't say that this is bad because it never happened before, right? So the fact that something is new doesn't mean it's bad, right? And that is just a very strange way of looking at the world, and definitely a very strange way of advising policy. There's other reasons why climate policy is such a mess, and that has to do with the role of science and scientists. In the olden days, the church offered a theory of two things, right? One is, how does the world work? And second, how you should behave in this world, how to be a good person, how to be a moral person. And that was the role of the church in medieval times. And in some countries in the world, it's actually still how things operate. In Europe, the Enlightenment separated the sort of how the world works from how to behave, right? And science sort of adopted this role of how the world, sort of took on the role of explaining how the world works. And in those days, in the Enlightenment days, it was still possible for somebody of reasonable intelligence and with a lot of time on his hands, women did not have that much time on their hands in those days, to understand the whole of science. And if you go back to the 18th century gentleman scientists, you indeed see that they dabbled in philosophy and in chemistry and in economics and in physics and in astronomy. They did all these things, right? That is no longer the case. By now, science is so vast and complex that we essentially have to accept what people say on face value. There's absolutely no way. I mean, I'm an economist. I'm a reasonably accomplished economist. I have a good knowledge of what is going on in my particular subfield of economics. I haven't got a clue about all the things that are going on in health economics and in labor economics, let alone that I know how, for instance, the internet works, right? It does, but I don't know how to build a webcam. I have to accept at face value that there's people that do this, and fortunately I can evaluate their claims and I can see, oh no, so that suggests that my webcam is working and his webcam is working and all the pipes in between are working as well. So essentially what we have to do is that we accept arguments based on authority, because there's no way we can actually, with our own eyes and ears, establish that this claim is true. And it's important that this is within a subdiscipline. And often things go wrong here. Scott Linnen here says scientists have again landed a spacecraft on a proverbial dime on a planet 40 million miles away. This is Mars. And the planet rotates at 241 meters per second. I think I'm going to trust them on this climate change stuff. Neil deGrasse Tyson, who you may know, essentially makes the same arguments. The scientists launched InSight from Earth and put it on Mars. Great achievement, and you have a problem listening to us about climate change? As if the same people do climate modeling as do space probes. Neil deGrasse Tyson again, we have produced the first ever image of a supermassive black hole 550 million light years away, and there you see the picture. And the response is, ooh, scientists, we have concluded that humans are catastrophically warming Earth. And the response is different, but the two groups of scientists are very, very different, that produced the first thing and that produced the second thing. This is a complete bogus argument, but one that is often made. So that is an important thing to note. Sort of post-Enlightenment, we are in the situation that the theory on how the world works and the theory on how to be a good person come from different sources. And a number of people find it confusing and start attaching moral authority to science. They just want this unified theory of how the world works with how to be a good person. And they sort of accept that the Bible story that the world was created 6,000 years ago was a lot of nonsense. I hope I'm not insulting anybody, but it is a lot of nonsense. And therefore the church is wrong, and therefore also the church teachings of how to be nice, that you should be nice to your fellow people, doesn't hold anymore. And I'm going to ask a scientist who at least knows about evolution and the Big Bang and what have you, and I'm going to ask a scientist on how to be a good person. And unfortunately, some academics, some of my colleagues quite enjoy that status, but of course it's complete bogus argument. Scientists, yes, are smarter than the average human being, right? You guys are already smarter because you got into this school. That means that you're above average smart, and of course to sort of become to get a master's and then a PhD and become an academic, there's a very stringent selection process there. So yes, scientists are smarter than your average human being. They're probably up in the 99.9 percentile, but just because we're smarter doesn't make us better people. And if you know anything about university politics, you would very quickly realize that academics are not necessarily good people, nor does it make us wiser in any sense, right? So that is just a very strange argument to make. And it goes further. Climate policy is very often phrased as a scientific imperative. And here we see the current Secretary General of the United Nations, Antonio Guterres. Climate action is urgent, the science demands it. And he's not the only one. Here is one of his advisors. The science demands unprecedented action. This is the leader of the Green Party in the UK. Climate action at a scale and speed the science demands. Eric Holthaus, a prominent commentator in the US, There's a huge gap between climate policy and the urgent demands placed on us by the bare truth of science. The Guardian, a letter signed by 154 Australian experts, demands climate policy match the science. Greta Thunberg arguing that we shouldn't unite behind the science. Kitty Lionel says the same thing. The problem here is that science does not dictate. Science answers the question, what if? What if we put more CO2 in the atmosphere? What happens to the climate? And if we want to reduce emissions, what should we do? If we raise a carbon tax of $10 per ton of CO2, what would happen to emissions? Those are the sort of questions that science answers. Science does not tell you what to do. The reason that politicians do this is that it essentially absolves them from the choices they make. And Sartre had something to say on this. This is a colleague of mine. Science can only predict the consequences of different courses of actions. It cannot tell us which course to take. Saying that you are following this science is, in Sartre's sense, a form of bad faith, pretending that you are not making choices when you are. I'll come back to this particular point. So politicians essentially hide behind the science. Bureaucrats also have a role to play in all this. So I talked about what we really want for climate policy is a carbon tax, a uniform carbon tax, and nothing but a carbon tax. In practical terms, a carbon tax is essentially an excise on energy and food. We already have excises on energy and food, and the only thing we need to do is raise those excises. And what you need is a small team in the Treasury to do this. It's as simple as that. You can do this for a country like the Netherlands. You can impose a carbon tax with perhaps 3 or 4 people, and that's all you need. Instead, what we have seen, and this is straight out of Niskanen's book, we have seen a rapid expansion of the number of civil servants working on climate policy. In a country like the Netherlands, it must be hundreds, if not thousands of people, probably thousands of civil servants working on climate policy. We don't have good measures of this. What we do have is what is going on in the international climate negotiations. In blue, you're looking at a number of meetings per year, which started with one, the Berlin conference that I alluded to before in 1995, but by now, the UNFCCC Secretariat, the Secretariat of the International Climate Negotiations, organizes between 50 and 100 meetings per year. That is a meeting every week, but more often 2 meetings per week. The annual costs of just the travel and the salaries and the hotel rooms and the food of these people now runs to $150 million per year. And it makes perfect sense. If you're a bureaucrat, then what you want to do is maximize your budget. You want to maximize the number of people who work for you. And that is what we've seen internationally. I talked about environmental movements. The environmental movement already, you want to cast your story in the old terms, and in many ways the message that you see in from environmentalists is almost taken out of the Bible, right? Emissions are sin, climate change is the final reckoning, but here is an opportunity to redempt yourself. And of course they do this to gather income and influence. Another thing that environmental movement offers is a tribe to belong to. This is, again, a US example where the Greta Thunbergs of the US have agreed not to endorse Joe Biden. Because, I mean, Biden's record on climate is not great. but it is much better than the alternative. Does this matter? Yes, this matter. What happened in the 2016 elections is that Jill Stein, the Green Party candidate, ran for president, and she took a good bit of votes in the three crucial states, Michigan, Wisconsin, and Pennsylvania. And if you look at how many people voted for Stein, who could have voted for Clinton, had they voted for Clinton, then Clinton would be president at the moment rather than Trump. So these things matter. The reason I believe that these climate people do this is that really what they're interested in is not so much climate policy and emission reduction, but what they're interested in is a sense of moral superiority. They want to be pure, they want to be seen as good, and they actually don't care so much about the consequences. It's just about appearances. Another reason that climate policy is complicated is it's become very, very big, very, very popular. And it's become a bandwagon for basically everything. You see 3 examples here. If you care about human rights and what you do, well, nobody's interested in human rights anymore, but everybody's interested in climate change. So you declare climate change to be a human rights issue. Or if you're interested in racism, then you say that climate change is a racist issue to attract attention to your cause, or gender issues. 2 other examples that you see here. Naomi Klein, of course, who has absolutely no interest in climate change until recently, but has had a long interest in capitalism, has written a book, This Changes Everything, like Hiccup, Horrendous Headache III always says, and has written a book about capitalism versus the climate. And of course, her thesis is that because of climate change, we need to overhaul capitalism. You read the book, it becomes very rapidly clear to you that she doesn't understand anything about climate or energy policy whatsoever, and her only interest is in capitalism. She is definitely not the only one who argues this. Ending climate change requires the end of capitalism. Have we got the stomach for it? So that leads me to the final set of players that I want to talk about. As I said, climate policy is often phrased as a scientific imperative. It's a categorical error. It's known as scientism. Of course, when you're confronted with this, you could try and explain, if you have 10 seconds on television, or you have to write a tweet, that this is just not the way policy should work. And what you could argue is that no, how much climate policy we want to do reflects our values. It of course reflects the positive facts about how the system works as well, but how much we really want to do is not because the science told us to, but it is because we picked a particular discount rate and we made particular assumptions about the cost of emission reduction, and we made particular assumptions about the impacts of climate change, and then we did a welfare maximization like Nordhaus does in his DICE model, and all these things put together makes us want to recommend this particular action. But if we had picked a different discount rate, then we would have come up with a different result. Right? That is the honest scientific answer to anybody's statement that we should cut emissions by 20% by 30% by 2030. That just doesn't work. If that is your reply, if you're opposed to climate policy, if that is your reply, you have lost the attention of your audience. It's much easier to say, and that is something that does fit in a 10-second soundbite on telly, is that the climate change is very uncertain, or there's no settled consensus on climate, or it is all a hoax perpetrated by the Chinese. That is something that fits and grabs the attention. So if you're opposed to climate policy, your best way forward is to simply say it's all wrong. And if you do not like an increase in taxes, or you have something against feminists, or you don't like development aid, or you don't like the transfer of sovereignty from the nation state to the European Union or the United Nations, or you don't like the trade barriers that are going up in the name of climate policy, or you don't like government regulation in the first place, if that is your worldview, and there's many people who are like that, then you can of course say, well, climate change is not really a feminist issue because the literature on this is very, very thin, and yes, it may be true that women are more affected by climate change than are men, because definitely if you look at people carrying water, it's typically the women that do it. So a drying of Africa would mean that women have to walk further distances to get that water. So it is a feminist issue in that sense. But then at the same time, an increase in energy prices would also probably hit women harder than it would hit men, and definitely if we talk about increases in food prices, then that would hit women harder than men. I'm not quite sure whether climate policy is really a feminist issue. You can make that argument, but it's a complicated argument, and if you want to be honest, actually the jury is still out, and it's all very ambiguous and uncertain. It's much easier to say, well, they've turned climate change into a feminist issue. I don't like feminist issues. I don't like feminists. I'm just going to say that climate change is a load of nonsense. So this sort of argument invites an extreme opposition. Unfortunately, climate change is far from perfect, far, far from perfect. So if you have something against the European Union or the United Nations, then the bad apples in climate science actually allow you easily a few sticks to beat them all up on. And that, of course, explains the extreme polarization, partly explains the extreme polarization of the climate debate. There's a lot of nonsense being talked on both sides of the equation. There's a lot of, on both sides of the debate, sorry. And that makes for very difficult climate policy. So to wrap up, I spent a good bit of time arguing that climate change is not an existential threat, but it is a problem. And I also hopefully argued that it should be solved, and it can be solved at a very modest price. The fact that climate change is a simple problem with a simple solution has not led to any sort of constructive climate policy or much constructive climate policy. And unfortunately, climate policy itself is stuck in a bad equilibrium with exaggeration, polarization, false promises, and what have you. I'm sorry that I don't have a more upbeat message to end with,